Well, good morning, everybody. My name is Keith Hewlin. I'm the Director of Business Development here at Ascent Geomatics Solutions. I want to thank everybody for joining the webinar. Looks like we got a pretty good group that's joined us today, quite a few attendees. We've got quite a bit that we've packed into this hour-long webinar, and we'll definitely hold time at the end for any types of questions. A couple things I just wanted to note before we get started is if you have any questions on the panel on the right-hand side with the orange arrow, if you click on that, you can submit questions throughout the webinar, and then we'll spend about the last 10 minutes or so, depending on time, trying to answer some of those questions. In addition to that, we're also recording this webinar, and so if for whatever reason you have to leave and go to a meeting or something like that, we will be posting this to our website within the next couple business days. So with that, let's go ahead and get started. So the purpose of today is to talk about the benefits of UAVs and LiDAR for midstream operations. Obviously, that was the title that you all registered for, so hopefully that's what you came to learn more about. The agenda we've got for today, we're going to be doing a very, very quick brief overview on Ascent Geomatics, and then just a quick presenter bio overview here, and then we'll go through UAV and LiDAR 101. We'll talk a little bit more about why UAVs and LiDAR in general, and then we'll dive into more specifically for routing and planning purposes, as well as built facilities. And then at the end, we'll kind of do a recap, summary, and then we'll give a quick slide on recommendations going forward. And then at that point, we'll open it up for questions. So at this point, let's go ahead and just do a real quick overview of who we've got in the room here. So on the left-hand side of the screen there, you'll see Michael Welker. So Michael joined Ascent in July 2013. He's currently the program manager for Midstream, and he's responsible for leading the project teams, project management, and technical expertise for utility grading, water resource projects, and all of midstream projects. He's a civil engineer with 17+ years experience managing land surveying, engineering, permitting, and floodplain projects. He has an extensive engineering experience in residential, industrial, and obviously oil and gas projects along the Front Range. His experience has included everything from surveying for topography, utilities, transportation, drainage, floodplains, construction, and as-built. Some of the projects he's worked on are the Carr Pipeline, the DBWI pipeline, is that right, Walker? Mm-hmm. All right. Water Pipeline, the Meadows, Red Hawk Terrain, Vestas, and a whole bunch of others, as well as over 500 miles of well connects and gathering systems throughout the DJ, the Permian, and the Bakken. He holds a BS in Civil Engineering from the University of Wyoming, an MBA from the University of Colorado, and is a CFM and LEED AP. I don't even know what that stands for.
Just some more letters.
A few more letters. All right, great. And then I'm also joined by Owen McKee. Owen is our remote sensing manager here at Ascent Geomatics. He has over 10 years of survey experience and has been with Ascent for 7 years. Currently, Owen manages all the remote sensing projects, including field work, utilizing terrestrial LiDAR, mobile LiDAR, UAV services, drafting or exhibits, project timelines, and budgets. He trains all the employees we have here on all those different systems I just mentioned, field collection along with traditional survey field methods to ensure that all of our processes and procedures are followed. Prior to joining, Owen worked for the City of Aurora, which provided him a lot of experience in the municipal space, adhering to CDOT, national standards, a whole bunch of other types of surveys. And he's also gained experience through drafting, updating GIS databases, control networks, and things like that. Owen holds a FAA Part 107 remote pilot's license and a certificate in GIS, and he holds BAs in both physical geography and archaeology from the University of Denver. And then again, I'm Keith Hewlin, Director of Business Development. I won't spend a whole lot of time here since I've got the two subject matter experts in the room here. So we'll just move ahead and move to the Ascent bio slide. So here, I just want to do a quick background for the folks that are not familiar with Ascent. For the past 11 years, Ascent Geomatics Solutions has specialized in collecting, analyzing, and delivering geospatially accurate data so that our customers can make more accurate and timely business decisions. Now, many of the people on this call are familiar with our former name, and you'll see it up there, Petroleum Field Services, or PFS in short. And in January of 2017, PFS decided to rebrand to Ascent Geomatics Solutions. This is due in part to some of the new technology that we've been using over the last couple of years and some of the new industries that we've moved into. Over the past 11 years, we've grown from essentially a one-person operation into a company that now employs about 80 people. With our headquarters in Denver and field offices in Williston, North Dakota, and Midland, Texas. Our main industry focus has always been, and still is, oil and gas. But as I mentioned, we also serve additional industries like transportation, civil infrastructure, land development, and mining. The core services that I'll talk about here in just a second, but being a survey firm first at our core, we believe in delivering extremely accurate data, whether it be with our survey teams, using GPS, or our remote pilot flying a UAV. And in addition to the extreme accuracy, we believe in fast but realistic turnaround time and uncovering efficiencies anywhere we can. That's really where this all came about, is trying to find out better ways of working with our clients. So just one more slide here on essentially the services we offer. So like I mentioned, we're a conventional land surveying company, as well as other areas that we are specialists in is civil engineering. Again, this is more on the areas of floodplain management, stormwater, grading plans, some of the things that dovetail very nicely into land surveying. And then in addition to that, GIS. So we've got GIS experts here in-house that work with companies of all sizes, whether they're a very large operator that needs us to manage GIS for a particular project, or a smaller operator that may need us to help manage their entire GIS as a company. And then permitting and regulatory, this is obviously on the upstream and the midstream side in particular. We do a lot of work with the federal, state, and local regulatory bodies. And then the main purpose of today, talking about UAVs and or drones, as they're commonly referred to, and LiDAR. So with that, I'm going to go ahead and jump into just a very quick UAV and LiDAR 101. You know, whenever we do these presentations, there's a lot of, we talk about a lot of terms, and so it's always good because you never know who might be listening and the education that they may have on these particular subjects. So what I'll do is just cover a couple quick basic terms here so that we're all on the same page as we move forward. When we say UAV, we're talking about unmanned aerial vehicles, or drones, as they're commonly referred to as. LiDAR is light detection and ranging. Essentially, this is 3D laser scanning, and it works similar to some of the other types of detection and ranging out there, like sonar or radar, where it's essentially sending out a pulse and then getting a return. In this case, we're sending out light, and we're getting millions and millions of these pulses and returns back. Now, there's a couple different types of LiDAR that we've used on projects. Terrestrial LiDAR, which you can see up into the top right slide there, where we have a person that's going to set up a tripod, and that thing will go in a 360, and we'll move that around a different location. Great for facilities. And then mobile LiDAR. So this is where you can take that LiDAR sensor, attach it to a truck, attach it to an ATV, attach it to a backpack, and really get done longer corridor or bigger projects much faster. So that would be better maybe for an as-built on a pipeline, as an example. And then aerial LiDAR, so just taking that sensor and putting it under a UAV, or in some cases, what's been used in the past is actual conventional planes. So a couple of the different types of UAVs that we utilize here at Ascent. One is a multi-rotor. That's the one you see up at the top that's yellow. That's essentially got multiple rotors on it, so it's better for flying a little bit lower, a little bit slower, gathers a little bit higher resolution, but the flight time is going to be a little bit less on that, and it's really kind of a different type of tool that we would use for a certain type of project. We also have the fixed wing, which you'll see on the bottom right, the black with the yellow stripes, and that is a UAV that we have, which is more of a conventional airframe. This is going to fly a little bit higher, a little bit faster, and generally speaking, it's going to go about triple the amount of time in the air. So these are much better for larger types of areas of land, and or for corridor type projects where we've got 10, 20, 50, 80 miles. We would definitely be using our fixed wing. And then ultimately, what we're gathering with all this data, whether it be UAVs or LiDAR, is point clouds. So point cloud is just a set of data points in a 3D coordinate system defined by X, Y, and Z coordinates. And essentially, we take this 3D model and we're able to deliver 2D deliverables, but we can also do a whole lot of other things with it. It's just a very dense amount of points that we can really slice and dice any way we want to give the customers the deliverables they're looking for. So we always get questions about the FAA and then local regulations, so we thought we'd just include this for the folks so that they don't need to ask these questions as we continue to go through. So in order to be able to fly commercially a UAV, you need to be able to have either a 333 exemption or Part 107. 333 allowed for us to be able to get into this game very early on, a couple years ago, because the FAA mandated that if you were going to fly drones commercially, you needed to have a actual pilot there as you were flying, and luckily our CEO is a pilot, so that allowed for us to get into this game pretty early. In August of last year, they created Part 107. FAA created Part 107, which allowed for a lot of different people to be able to go out and get their remote pilot's license. They just have to go in and kind of take a written test and pay a little bit of money for it. So that's good and it's bad, and I'll talk about that towards the end here when we kind of wrap up with recommendations. But we also have our Part 107, and we have a number of pilots in-house that have their Part 107 remote pilot's license. BVLOS, so a lot of folks ask the question, well, how far can these things fly, or how high can they fly? And it's really not a limitation of how far they can go. They can go quite a ways. The limitation right now is this beyond visual line of sight. Currently there is a restriction from the FAA that you must be able to see the UAV. You must be able to, and not with binoculars or any other types of tools, you have to see it with the naked eye. And so generally speaking, Owen, I mean, how far is that you're able to see and not lose it?
Well, if I'm clear-eyed, probably about 3/4 of a mile from my location. So in a corridor concept, that's 3/4 of a mile both directions. So we can collect about 1.5 miles of linear line at a time.
Right. And now there are, and I'll mention this in a second, about waivers and permissions and things like that. But because we have our 333 exemption, one of the things that we were able to do is actually put in for a exception to that, or a waiver, allowing us to get beyond visual line of sight. We are about 9 months into about a 1-month process. Obviously, you know, in some cases things don't go as fast as you would like them to go, but we expect to be hearing back on that shortly, and that would allow for us to be one of the few companies that can actually go beyond visual line of sight. Now, another restriction is notification within 5 miles of an airport. This is an FAA standard or regulation. Now, generally speaking, you may be able to get within possibly 4 miles of an airport if you're putting in a waiver, a smaller airport. But you're basically probably not going to be able to get any types of permissions within 3 miles. So this is a key thing that we look at when we're looking at a project, is just how close are we going to be to airports. We also have takeoff and landing considerations here. We really just need permission to take off and land. We are able to, legally, we're able to capture data from the air over people's property and with no issues. It's just we need to be able to take off and land, and we have to have those type of permissions. So, and we'll probably talk about that permissions with landowners here in a little bit. And then local ordinances. So a lot of different local municipalities have just a basic ordinance against flying drones, and I think it makes sense. They don't want 50 people every single Saturday morning, or thousands of people every Saturday morning putting drones up in the air, and it just wouldn't be a good situation. So they basically put a blanket across it saying you can't fly drones, and all we need to do is get a waiver, and frankly, we've never had an issue not being able to get permission to fly with local municipalities. They basically just want to come out and watch us do it. And then last but not least, as I mentioned throughout this, there's always waivers, permissions, which are essentially exceptions to the rules that we're, in most cases, generally allowed to get.
And then one last thing, Keith, is the height we can fly. So there's that visual line of sight distance you were talking about. There's also a cap of 400 feet above ground level that we cannot fly above, because we get into a different type of airspace a little ways beyond that. So FAA does say we can't be at a certain height above ground.
No, that's a really good point. And I don't know if we'll mention it down the road or not, but when we're using this type of technology, depending on the type of UAV or drone we're using, in some cases, landowners or other folks, they don't even know it's up there. I mean, our conventional aircraft, our fixed wing, it essentially looks like a big black bird that's flying up there. You can't hear it. It just looks like something's flying above, if you're even paying attention to it. Yep. Okay, so why UAVs and LiDAR? So from a high level, when we talk about UAVs and LiDAR, we're just talking about the evolution of data collection tools, right? I mean, surveyors have been using various different tools for, frankly, thousands of years. But, you just go back 100 years or so ago when they were using transits, and then you kind of move into this evolution of using GPS, total stations, and some of those types, robotic total stations, some of those types of equipment. And now we're just kind of in that next evolution of using different types of tools. We're still conducting a survey. That doesn't change. Sure, there's other byproducts that come about that you weren't able to get before with other tools, but we're still conducting a survey. We're just doing it from the air or using LiDAR to help conduct that survey. What's interesting is, some people are reluctant to look at some of this new technology, but it's interesting because GPS, obviously, 20 years ago, had the same viewpoint of, well, I'm not sure if maybe we can trust that 100%, and we need to test this out. But the reality is that this is the standard today, and we believe firmly that drones and LiDAR will be the standard moving forward. But we've just been able to kind of get on the front end of it and really kind of proof this out and make sure that we've got a workable product to deliver. So, high level benefits of UAVs and LiDAR for upstream and midstream operations. There's a lot of different benefits, but ultimately they're the same. They're safer, more data, less time, and better deliverables. So safer. Well, generally speaking, we have less field time. So we're out in the field less, which obviously reduces the frequency of incidents that could happen. We're also going to be not, walking around in these rattlesnake-infested fields that our surveyors all love to walk around in. And just generally speaking, we'll show some of these other examples. We're not having to get in trenches to get information and things like that. So overall, it's a lot more safer than our traditional types of methods of surveying. Now, I do want to mention real quick, just so I don't forget, there's still a ground component to all of this, and there's still a piece that we're going to need to go down, and we're going to set control, and there's still going to be a ground survey component to all of this. It's just that it's much, much, much less. So we're just we're not saying that it's 100% safe, because I'm not sure anything is. We're just reducing that incident rate quite significantly because we're just in the field less. More data. We're able to get a tremendous amount of data. And some of you may be thinking, well, that's great. Who cares? Why would I want more data? The reason would be because instead of just sending a crew out to capture a little bit of data here, then go back out, catch a little bit of more, collect a little more, collect a little more, we're able to get, for the most part, almost all of that data on the front end. And then when it comes time to do things like reroutes and things like that, we've already got the data. We don't need to send anybody back out. We can just pull it up on our screens, and with topo and culture and all these other things, we can decide where we want to go with it. Less time, I mean this in two ways here. Less time in the field, for sure. There's a way less time of a field component here because we're flying instead of walking around or even on ATVs. And then I also mean less time in the overall project. So these efficiencies that are gained by not having to send crews back out to these locations again and again is really important, and it does create a lot of efficiency. So I think there's savings in the overall project lifespan. I don't have empirical data to share with you all today on what that looks like, but we just know anecdotally that we've heard from our clients it's definitely helped to increase efficiency. And then better deliverables. Ultimately, we're still going to be able to provide the 2D deliverables that our clients are used to getting today, but we're transitioning into also providing 3D deliverables that help them make different types of business decisions. So a little more of a detailed list. I won't go through all these because I just got done mentioning a few of them on the last slide. But one of these would be, fewer return trips to the field. I kind of mentioned that. That's a big one. Not having to go back out. Obviously, every time you go back out increases the safety factor there and takes more time and obviously overall cost to the project itself. I think just increased project planning on the front end when you have that much more data, you can really plan a lot better. And then I would also mention engaging marketing. So, this can be good for a whole bunch of different ways of using it from a marketing purposes. If this is obviously, pipelines have been getting a lot of attention the last couple of years, and so being able to go out and maybe fly that route and get information on the front end as to pre-construction, maybe post-construction, some of those things, but also just to provide to maybe some of the landowners and things like that as well. So there's a lot of marketing sides to this as well when you capture that data, and everybody loves a bird's eye view. So anything else I missed on that?
No, I think, public outreach, that's a big component, that it's a side product that we're getting while still collecting real survey data. We get all these visuals, and we'll dive into a couple of those here in just a little bit. Kind of really wanted to go into the next steps of what is a point cloud and what do we actually get out of all this data. So you'll see on the screen, we kind of have a little comparison we mocked together of conventional survey versus a UAV or LiDAR survey, and depending on your densities and your collection method with either UAV or LiDAR, the point density is going to vary. But for an average photogrammetric, which is basically a series of photos being stitched together in a 2D and three-dimensional sense, we're able to get a significant amount more data in between within a square space. So conventionally, we'd send a surveyor out, and they will hit any key grade breaks, any key features that could have an impact along the surface, that it could impact your grading or the amount of earthwork that you have to do to make a project go to completion. They're going to get on a 50 by 50 grid, maybe a shot every 50 foot. So talk about 4 points maybe for that given space. Within that same area, if we're using alternative collection methods, we can be getting up to 2,500 points within that same space. And so it's not to say that surveyors are going to be missing key points, but there's small undulations across the course of an entire project that, if you look at this lower right example, those small undulations in earthwork could actually make a pretty significant difference in the amount of earth and the amount of time and the amount of product that you have to deal with on the back end, that UAVs and LiDAR can really help kind of mitigate and give better intelligence on for front-end planning.
Great. And so maybe we could talk just a little bit, Owen, about kind of 2D versus 3D data.
Yeah, exactly. And again, and we're saying 2D in the sense that it's a two-dimensional plat. It's an alignment sheet. It's a literal paper-style product that everyone still needs to get work done. We're still going to produce that, and it's based on survey points, which again are 3D points, but it's just displayed and shown and really put out there in a two-dimensional platform. We're able to take this drone data, still produce that, and then create these three-dimensional point clouds and 3D meshes and all these other type of products, which you'll see on the right side of the screen there, that just give a whole other element, which we'll dive into the benefits of EH&S and progress reports and enhanced routing and planning perspectives here in just a little bit. But the idea is that we can take the right side three-dimensional data and still transform it into the standard products that you would expect to receive.
Great.
And then, again, kind of all over benefits that we have. Location reconnaissance, that's huge when you're dealing with corridor concepts. There's a lot of features that could get in the way and a lot of different items that could cause either minor or major reroutes as you're diving into a site. Most people hop in, use Google Earth, try and plan out on the front end. That's a snapshot in time from a certain season. You may not notice a wet area or just other potential items that could cause issues. Location reconnaissance is huge in order to be able to get enhanced route planning using these type of technologies. Then, as I said, there's a number of other items that you can get through, which we'll go into here in just a little bit as well. And then LiDAR benefits, especially once that pipeline hits the facility, understanding how everything ties together. It could be at valve sets, at facilities, really getting a very tight three-dimensional view and a view that you can eventually turn into a model for kind of getting to the next step for expansions and retrofits. Basically, you can take these point clouds, these millions of points, and develop it into a variety of different products. And again, we'll dive into that here in just a bit. And then ultimately, once again, it's safer with more data. We can get views that look like someone's in the trench or someone's in the facility that actually is not. And so it's a great way of seeing different perspectives while keeping people away from issues of being intrinsically safe or with earthwork that could fall in on them.
Okay, great. And thanks for that, Owen. So, next what we're going to just dive into, again, high level, and then, after this, we'll get into basically a lot of examples. So we're going to be showing a lot more media and visual examples of what this actually looks like. But just for the sake of understanding high level, where are some of the applications for UAVs in midstream? Michael, you want to just talk to this one real quick?
Yeah. So kind of the basic tenets of using UAVs for midstream is on the front end. It's very applicable to doing route planning. Typically, our workflow, we get a KMZ or something from a client, and we can go ahead and plan out our flight for that KMZ. But during that collection, we're collecting a much wider swath. We can go back and review that route with the client and make minor reroutes based on cultural features or topography that we pick up during those flights, and kind of finalize those finalize those routes. And due to the fact that we collect such a large swath, we're able to stay within the data set collected, while well, if we did it conventionally, we would maybe have a 200-foot wide window. So routing around some features that were not on Google Earth or whatever while we're in the field, we're able to leverage that data collected and do reroutes on the fly without having to go back and collect that stuff. We obviously can create it faster. Typically, we have a couple to a few miles with conventional boots on the ground. We're sitting at somewhere between 5 and 7 miles for UAV collection, so it's a multiple quicker to use the UAV, and it's obviously that's more efficient, and we can kind of use these flights both on the front end and during construction to report construction progress. Another application that we use UAVs for is permitting. So, pipelines almost always come across some sort of water feature, and there's some sort of floodplain permitting, so that we can fly these cross sections to submit these floodplain permits very quickly, where it would take maybe a whole day to do it. With conventional, we can do it within a matter of hours. And then kind of stormwater permitting or erosion permitting, we can use LiDAR to effectively monitor that and inspect.
Great. Okay, so now we talked about these kind of two major topics, UAVs for routing and planning, and then a little bit later, talking about facilities and LiDAR in particular for that. So with that, I think let's go ahead and dive into some of the different types of deliverables that you're able to get when you're from a planning and kind of front-end standpoint, Owen.
Yeah, definitely. So you'll see on there, this is just an example of one of the routes that we've flown. This is during construction, obviously. But the idea is we go out and collect this same swath. We're able to go out on the front end, establish control, really approach it from a survey sense that we want to be able to get as much as we can the first time. So by establishing all that right at the front end, when we go back during construction here, this is a really quick process to go out and fly this. We already have our base down, so get up, fly it, produce new imagery, see what type of information you want to gain from the actual flight data during construction and beyond. But primarily, it's really about how do you better and more efficiently plan it out. So you'll see that there's segments along this line here that we weren't able to actually go through, and that's where there's something from a route planning standpoint. Maybe you don't have continuous ability and permissions to be able to go out and have a guy on the ground. We can still go out and overfly that zone and collect that data, so that way we can, again, make sure we prevent any major or minor route changes during that initial process. And ultimately, we're able to collect any and all visible features. So as far as any sort of cultural setback type items that Michael just referenced, water features, we're able to get ahead of that and really define it out. And then on top of that, beyond this, all of our 107 pilots are actually land surveyors by trade. So we're not approaching it in the sense of just a UAV. We're approaching it that we know we need to get topography out of this out of the very front end when we're doing the route planning. So we're going and we're going to tie it all together and make it actually a real survey set of data while we're on the ground. And so we can generate the topo that we can use in the route planning and the alignment sheets down the line.
So you're saying that your team isn't just going out taking pretty pictures?
Yeah, exactly. There's features that you're not going to be able to collect from the air that you have to understand on the front end, that if you don't get it and you just rely on the UAV to try and see that, you're going to miss it. You're going to wind up going back. And once again, that pushes back timelines, deals with a number of issues. And we approach it that we will not have to do that because we understand what may or may not be visible and usable at the front end.
Got it. And so again, what we're, essentially this orthomosaic we're looking at here as an example, what we're really talking about, if I summarize what you just said, is you've got data and you've got the up-to-date aerial imagery that couples with that data.
Exactly. And I think if you advance to the next slide here, I have an example here to kind of show you for a proposed route. You can see a kind of major ditch canal running through the center of this example. You can see all the small lines. It's all the topography we generated from this roughly 1,000-acre space, I think. I measured it out. We were also able to take the setbacks. We had to be off of certain building units, and there's other items that we have to take note in order to be able to effectively route and plan out both pipeline and facility locations. So this is kind of the type of product that we're actually getting out of it, and then ultimately those aerial images we can add into things like Google Earth, so you can see that with the road features, and ultimately it just really increases your route planning. And again, if you want to advance to the next screen, Keith, we can dive into that a little bit.
Sure. Well, real quick, I just have two questions that I'm thinking of here. I'm sure a couple people are thinking about. So what we're looking at is an orthomosaic here. You said this is about 1,000 acres or so. So if somebody is actually going to be, you could zoom into this, right? We're looking at it from a very high level, obviously, if this is 1,000 acres, but you could zoom in on this property, all this land here, right? To what degree can you zoom in and actually see what's on the ground here?
Yeah, I mean, we flew this at roughly, the resolution was 1 pixel per inch. So you could zoom in and you could essentially make out or see your phone, your cell phone on the ground, get down to that level of resolution. Now, that's a really massive file to deal with that. So what we do is we figure out what type of platform you're running in, what type of CAD platform, and we'll actually downsample it, which is basically sort of reducing the size but keeping the integrity. And then we'll also turn it into what's called tiles. So that way, when you're moving around in your actual planning programs, it's not going to slow down your program and cause a big issue. You can still have a really nice resolution that you can see your power lines and your fences and anything that could be a major hindrance for any type of planning.
Okay. And then last question here, and then we'll move on. So accuracy. We're just talking about UAVs, photogrammetric data here. What type of accuracy? Generally speaking, I get that it can vary, but generally speaking, what type of accuracy are we looking at?
Yeah, so two-dimensionally, horizontally, that is, we're right at survey grade. We establish control, and we approach it with a real survey. So all those features that we have drawn in are 100% at survey grade. So, a tenth of a foot or less, no problem there. The three-dimensional side of it, the elevation, depending on where we're at, we find all over average values of about 0.3 of a foot plus or minus, which is about 4 inches, give or take. And then if we're able to fly it when it's either brownfield or in the off-season of growing, we can tighten it down from there as well. And we can get down to values of maybe just around a couple inches plus or minus, which for a lot of the work that we do is great intelligence.
Okay, great. All right, I'll let you off the hook and move to the next slide. All right, so what are we looking at here?
Yeah, so once again, this is just an example from a client. They were planning out a new location. You can see on the left from the same day was the Google Earth image that we took to help plan the location of where we were actually going to fly. And then on the right was the next day we were able to produce out this imagery. And you can see there's a new, above ground pipeline, which actually is down in Texas. So you'll see that they do some above ground work there. And then you see something that's below ground. That last arrow that popped up, it's a new pipeline corridor that you would not have seen. The client was planning on tucking a new location right into that very corner, and there was about 100 foot of space there that they were not going to be able to use. So as far as being able to get their permitting and getting their site kicked off, it would have had an impact. So by having this front-end flight intelligence, they can better piece together what they need.
Yeah, so, and just to make the distinction here, right? I mean, we're not telling folks not to use Google Earth, right? There are purposes and reasons for using Google Earth, and maybe even, pre-planning, just kind of generally getting an idea of where we may want to kind of put this. Certainly you could use Google Earth for, right? I mean,
we do that ourselves.
Sure.
That's how we completely plan out. But the idea is that we can go and take this imagery, and you literally get a KML from us, and you can plug that in, and you can have all your Google Earth features with that new imagery under it.
Right. Yep. And so I think we actually have an example of that right here, right?
Yep. Yeah. There's a great example. So you can see that swath that we collected. Just again, it's same day of what's on Google versus same next day of what we processed through for imagery. One of the big things that we can counter and get ahead of, which there's huge issues in Wyoming, down in Texas, every state, that there's unknown pipelines, there's scars that may be new. You may not have your title work done yet, so you might not know where all the potential issues are below the ground. You can see some of these scars, especially on a new pipeline. If we're able to go out and fly it, we can see that ahead of time and try and get in front of it, or even help aid in the title research itself to try and figure out who owns what and what actually is in the ground there that could be a hindrance.
Yeah, and so just for the folks on the call too, I don't remember when we actually flew this location. I don't know, months ago, I'm sure, right?
I think this was in the spring because, yeah, it looks like it's before the green season there.
Right, so this was actually, when we say UAV up-to-date image, it certainly was up-to-date that day. I just for kicks, I pulled up Google Earth yesterday, and that's actually what Google Earth still shows as of yesterday. So just to kind of, as we all know, using Google Earth, it can be 3 months or 3 years old. You just never know. And obviously, as you get further and further away from the metropolitan areas, the less and less updated it really is. Okay, so let's look at an example here, and I want to preface this next piece. This is a video that we're going to be showing. It'll be really smooth on our computer here, but it may look a little choppy just going through this GoToWebinar connection. So if it's kind of seeming like it's coming through and a little bit slower, just bear with us. If you'd like to see what this looks like in actual kind of real time, let us know. Now, before we show this, I think it's important just to mention, what we're actually looking at is data, right? Yep. We're looking at data that also obviously has that combined imagery to it, but this is not one of our drones that's just kind of flying, taking video. In fact, you can see off to the edges there that it's not.
Yeah, I mean, this is kind of during construction, but obviously in basins where there's a heavy corridor, this wouldn't be uncommon that this is your planning phase where there's already construction going on and you're trying to abut against it. So kind of what we're really trying to show is when we're doing the planning phase, we can see roads, like for instance, we just went over that we're going to have to bore, which was a bore we just did. You can see kind of in the far off distance, you can see a landowner that we had to bore completely because of restraint. If we weren't able to get permissions on that, we would see that we could collect that data. As you can see now, this is the actual data that sits underneath that mosaic, and we are able to pick up just a numerous amounts of data. You can tell the width is closer to a 1/4 mile, so if we had to do that with boots in the ground, it would just be exorbitant. You can see some features where there's like a water feature where we may not be able to penetrate, but I think, as Owen indicated, we have qualified surveyors as our pilots, and they know to dip those locations as needed to supplement this data. But all in all, you could see that the data set is rather huge and something you probably wouldn't want to pay for if you were doing boots in the ground. But in this instance, we're able to utilize it for the HED design, which I think at that point was over 1,000 feet. Some other things you could see is you could see a wetland area right there, so we can keep track of workspaces and make sure that folks are staying inside the right-of-way that they're required. This also can be tied into when we do inspections for stormwater permits, MS4 permits, and we call them swamps and stuff in Colorado. But some of those requirements are disturbance areas and keeping BMPs or best management tools to keep unsettled ground outside of waterways. And so we can do the inspections in the air during work progress and give updates to clients.
Okay, great. Yeah, so leading right in and kind of along the same lines, Michael, you want to kind of talk about UAVs as-built purposes?
Sure, yeah. And so we're really excited and, to be utilizing some of this data for as-builts. And I think this is some indications where we have still have maybe a tie-in or two in this indication, or some pipes are being rolled over. So kind of an indication that we're about to bury some pipe and some pipe's been done. So we can actually do some of these as-builts during construction where maybe we can fly it and quickly get that data, as opposed to standing out there. I know when we build a pipeline, there seems to be 10 people working like mad and 50 people standing around looking at them. And we probably get our fair share of anecdotes on that. But I think this is an indication where we can come out at the opportune time and fly the route and collect that as-built data. So this is kind of an indication of that. And I think, I think we have a video coming up of another as-built as we were flying.
Yeah, just to point out that if we're out there collecting updated orthomosaics or getting anything for versions of progress, sending a bird up to get these type of photos or literal video is really quick and easy, because not everyone can be on site at the time. Everyone, someone sitting back at the office may not be able to see the construction progress, and a point cloud may not be the right vessel to kind of portray where it's at. It's a great, progress and as-built tool that is just something that takes 2 minutes to get done while already there conducting a survey or an aerial orthomosaic.
Great. So this next one, this 3D point cloud fly-through, now we're actually looking at, and we're kind of jumping ahead a little bit, this actually has LiDAR data in it, but Owen, you and I were both on location here, but you were actually doing the data collection. You want to kind of walk us through this one as I hit play?
Yeah, definitely. So again, this is a proposed corridor, and in fact, right now, this is obviously, as you can see, it's an as-built, it's under construction. It was paralleling in an existing utility corridor. You can see the transmission lines there. We kind of gave a little aerial view there to kind of give you perspective on what the LiDAR data is showing. But essentially, what we were able to do is go out, and in just a little bit here, you'll actually see the collection method itself. But we collected this with LiDAR on a backpack. So it was a mobile LiDAR system that we can measure out the size of wire, the sag of wire. We can, again, calculate into that disturbance, see are we staying within where we were permitted and where we're legally allowed to be, and ultimately figure out if there's any additional data pieces that we can collect this on the front end for routing. And again, also, once we have that control, collect it for the as-built as well, or progression. You can actually see right now there's a guy down there with a backpack. That's the system that we use, that we can just walk around. We get all that detail in the bushes and the shrubs down there, and just an immense amount of detail, all off of a literal, this path, I think was probably 15 minutes worth of walking, and we got all that. So we use that on corridors, and then we can also use it for facilities. It's detailed enough that we can actually collect valves and small pieces like that that require that sort of millimeter style detail and accuracy.
Great. So moving along, another area here, Michael, maybe you can speak to this one, kind of this vegetative regrowth concept.
Sure. I think you kind of saw where there were some disturbed areas, and we can always, since this is always georeferenced data, we can always overlay our proposed route to that and see any deficiencies or any construction that's outside those routes. So we can utilize that data with our right-of-way agents to let them know that they may need to pick up some more temporary workspace during construction based on reroutes or whatever. This is kind of illustrates part of our process while we're doing these stormwater permits, where we're able to use a different spectrum to analyze regrowth, and most of these MS4 permits require a 70% regrowth before you can kind of wrap up the permits for those tracks. So we can go fly the line and track by track clear those tracks for that requirement. I think not only does it help with permitting, but also those back-end negotiations with the landowner that do we have regrowth yet? And we can date, as of, 7/20, we were able to show that, you do have 70% regrowth, and that will help with the right-of-way agents closing those tracks out.
Okay, great. So just to kind of finish out this section, you just want to kind of, Michael, if you don't mind, you're
Sure.
on a roll, just kind of keep us through the various deliverables.
So we kind of been hitting a lot on the front end and during construction, but I mean, all these data collections can be used for Exhibit A's. Obviously, there are some breakdown considerations that we have to use, boots on the ground, but we can collect that while we're collecting this data. But permitting exhibits, we talked a lot about stormwater permits. It's one of those things that most people kind of put aside until you get a stop work order, and then it becomes the most paramount of permits. So we can stay on top of those kind of exhibits and inspection. HCD boring profiles, we kind of showed an instance where we didn't necessarily have permissions to get on a property, and we can fly those, legally able to fly those properties while, typically when you're doing a line, there'll be a couple holdouts, and it'll kind of back up the process of getting bid issued for bid sets out. So we can go ahead and fly those properties, continue with the progression of getting those alignment sheets organized, and so the project can stay on time. So utilizing this technology, we're able to stay on time, where before it'd be the same conversation in meetings where we don't have permissions. And then some of the deliverables for like data sets is we'll have point clouds in case there's some need to integrate that information into another deliverable. And obviously, I think we've kind of hit these enough, but the fly-throughs for sort of upper end managements that want to see how their projects are progressing. So I think kind of those weekly, monthly report fly-throughs, that these are also, while collecting data, are very valuable.
Okay, great. Thanks, Michael. So that was kind of the section on planning and routing and specifically UAVs, but we did start to incorporate some of that LiDAR discussion now. We're going to be kind of talking about UAVs and LiDAR, and specifically LiDAR for as-built and facilities. And to do that, Owen, do you just want to kind of take a few of these next slides and walk us through them kind of quickly here?
Yeah, definitely. So again, on the left here, you'll see something we just kind of mocked up as far as if you're doing a compressor station build out, you're trying to get a facility location permitted. There's a few different methods that can be followed and different workflows, but we just took a stab at this. There's key parts that seem to get missed on a lot of projects that we've encountered, and that's what the left is kind of outlining. There's certain parts that you do hit, you have to hit, and then there's other parts that get overlooked. Ultimately, that creates numerous challenges and affects your business outcomes, ultimately, if you're missing key points. And how do you get more of those key points hit at the same time without increasing the cost? And essentially, these tools can help with the efficiencies and reduce risk at the same time for the ultimate outcome. So essentially, looking at side by side, once again, I kind of touched on this before, but you collect what is requested at the time when you're going conventionally. You're not going to collect a full section of land the first time out there. The budgets don't allow, time doesn't allow, it can be unsafe. Versus using a UAV, you can collect that section of land in less than a couple hours, and you just get that much more build out on the front end, and you get all the same deliverables as we've said before, but you get a lot quicker turnaround, and you get these enhanced deliverables that we keep referencing. So kind of on the left here and then on the right. So ultimately, what do you need? You need your standard facility drawings, your general arrangements, your ISOPAC drawings, P&IDs. All of those we can still produce out of these 3D data sets, but we can also ultimately turn it into a real 3D actual modeled facility like you'll see on the right there. This is a location that a client asked us to do a full model project on. And you get the piping, you can get down to flange details, so if there's fabrication to be done, we can tie in and help them with the manufacturing of that based off real data that we collected months ago. And then ultimately, again, with these items, if you're building a new location, you like to think that your crews built them as you planned. So you still are going to create a grading plan style product on the front end. They go out, they build, compact, add on whatever base they need. If we go out and we refly a location really quick, we've already been out there, we can update the elevation data so that way if your underground piping models or your above ground facility models need to be adjusted because of the vertical difference that was created during the actual construction process, we can get that, use that to update the model up, down, left, right, and really make sure it's going to go in exactly where you want it.
Okay, great. So maybe we could take a look at a couple of these examples and kind of show examples of as-builts that we've worked on with some clients.
Yeah, definitely. You know, you'll see here. So this was taken from a photogrammetric data set, an existing pad that was under construction, being drilled out, and then a production facility that was being put together to go online. Nice thing about this, from an EH&S standpoint, if someone back at the office wants to be able to look at what's going on the site right now, you can see if BMPs are being followed, you can see all the swales and berms, and you get all this data off the front end. And at the same point, you're still getting the actual survey data for the as-built itself that you need to kind of create those tangible deliverables or those models further down the line.
Yeah, so we're here, you know, if I can jump in, we're kind of looking at the as-built from a higher view. So let's call it a 400-foot view, getting that as-built, because everything we're looking at here is data, right? Yes, there's imagery coupled with it, but this is all just a massive point cloud, what we mentioned before, point cloud. This is just a massive data set. And then what we're able to do is take it one step further, and then maybe not from a 400-foot view, but down to a millimeter type of view, is we can take these data sets, the photogrammetric data sets we may get from UAVs, along with the LiDAR data sets we get from whether mobile or terrestrial LiDAR, and combine these. So now we can take it from a 400-foot all the way down to you know, literally a millimeter type view, and get more of a understanding of what is actually going on in this facility. You'll see blue, you'll see white. This is where I think we have an example here in a couple slides where we actually show something that a facility that's fully modeled. But this is where we've shown how you can start to kind of model some of these you know, different areas of the facility out.
Yeah, I think you hit on all those good points there.
So you know, next maybe I'm going to see if we can do this. It's the first time I've tried to do this, so we'll see if we can show our true view. But maybe you could talk through this, and I'll go ahead and see if I can pull it up here.
Yeah, so the actual LiDAR data set that we can get on the ground with these static units, we have these viewers that you can have online that someone can literally get a login and go to, and they can literally become the head of the scanner. So it's almost a street view, Google Street View perspective on these locations. So you can click, and the different setups and stations that we are at, you can go in, we colorize them, we get them completely registered together. So it is a actual, I think, oh, good, there we go. You might be seeing that on the screen now. So we're trying to get a real perspective that you can measure within this colorized point cloud. You can see points. Someone can pull this up on a tablet or on their smartphone and be inside the facility. And Keith here, he can click on this and kind of show you what we're talking about. So this is, once again, millions of points put together, overlaid with imagery that we collected at the same time. This gives you that boots on the ground perspective without actually having to be on the facility. These units, also to note, are completely intrinsically safe, so we always take safety into account when we are collecting these type of data. Then ultimately, you can register actual measurements and share and annotate them with your kind of crew and your work group as well.
Yeah, so this is a request that we actually get all the time, right? Is what's the bolt pattern, or
yeah, what's the dimensions? What's the size of flange? There's a lot of information that you wouldn't get in a conventional survey, or it'd be really hard to portray that type of information. And with this, they can go in and pull that. And if they really do need detail and they need that model to fabricate on or add on to it, we would just take that data and extract it out. We're not going to always go and model an entire facility if our client doesn't need it. We're going to give them the pieces that they need and that they want, and then extract that information and serve that up. And then when they want more information, we'll be able to provide that. And that goes for whether it's a LiDAR data set or one of those UAV-based photogrammetric data sets. We're not going to give you everything. We're going to give you exactly what you need at the time, and then have all that information available for when changes do arise.
And so over here, when we talk about these stations, we're able to, these yellow triangles, we're able to just kind of run through really quickly and basically take a trip around here. We don't even need to be sitting there. So for operations that run out of Houston or Oklahoma or whatever, and the site is in North Dakota, obviously it's a great way, as long as you have internet and a username and password, to be able to get in and actually see the facility firsthand. Okay, so let me switch back over to the presentation here. Hopefully this will go smoothly. All right, let me, okay. So let me just change one thing here. Here we go. Okay, so back to it. Maybe we could talk now a little bit about modeling, if you don't mind, Owen.
Yeah, we'll just run through this really quick, but this is yet another example from a client that we've worked with where we were able to put together a full 3D model that you'll see here. You can get every level of detail. We can model down to a really fine level of detail or keep it really at a certain perspective. So do you need all the way down to your small half-inch conduit wiring, or do you just need to know where your main piping infrastructure is? It's just something that we work out on the front end. We always figure out what do you need to get to in the end, and we work our way back, and that determines how we approach it from the field. So it's always that farm-to-table perspective that we need to know what you need, so that way we can make sure we collect it, and then we extract it exactly to your standards.
Great. So a couple real quick things here. So obviously one of the safety factors here, staying out of the trenches, is a big concept for us. We've been working with a lot of providers on everything, all this scan data that you see here. You know, on the left you'll see, and this is not us by the way, but this is obviously what you'll see a lot of times with surveyors. This is just not safe. We're able to collect 1,000 times more data in a way safer manner, be able to do a lot more with those deliverables as well. And then, you know, ultimately this is kind of that same idea. Owen, real quick.
Yep. Yeah, you just see here, this is a well pad and the well connect tying into the facility pad right here. And then this is one that has multiple well pad locations tying into it. So a couple different connect lines and routes running through there. We're able to, again, get it as it's going in the ground. And then here, once again, you can get these trench perspectives without actually having to have a single person in the trench. These are all collected from outside a trench in safe zones, but we can give the client that perspective.
Okay, great. Real quick, layouts and permitting.
Yeah, once again, Michael already touched on it. We can just come up with different view types to help enhance, you know, USR and municipal, county, any type of permits that are needed for both facilities and on the midstream end.
Great. And obviously, you know, I think adding all this into an asset management system goes without saying, but you know, we provide services there if you guys would like to hear more about that. But obviously loading all this into a GIS system is critical as we move through. Anything Michael or Owen you'd want to say on this?
Yeah, there's always customization that you can do. Whatever product you need, we can output it. It's different data for different needs.
Yep. Great. So again, quickly, various deliverables. We're still giving standard deliverables. I hope that if there's anything that you take away, if you're used to getting 2D as-built plots, you can still get those. We're just taking it out of 3D data. It's everything else, the point clouds, the feature modeling, the orthos, the up-to-date imagery, and the fly-throughs, all these other different types of byproducts that you can also get that we can also deliver. So kind of recapping here, you know, we do take a blended approach to this. It's not one, you know, one tool for one job. A lot of times we're using a blended approach where we're using UAVs, we're using LiDAR, and we're using conventional methods. It really just depends on the delivery method that, the deliverables, I should say, that the client is actually looking for. And that kind of leads me into some of the recommendations. You know, number one, obviously I'd recommend working with a company that's got oil and gas experience without question. You know, just so the terminology and the experience and expertise is there. Two, survey firm. With the Part 107, there's now 150 companies. Just in Denver alone, you could probably call to go do flying with drones. I want to make a clear distinction here. We're talking about gathering geospatial geospatially accurate data, survey grade or if not design grade type data that you need to use to make business decisions. We're not talking about videos and just imagery and pictures. There's a lot of companies that do that, and I would recommend, because we get these calls every week, that you work with a company that understands that this is still a survey that needs to be conducted, because that seems to be where a lot of companies fall short, and they don't actually get the data that these other firms or operators are looking for. Full service collection, analysis, and delivery. So this isn't just about flying drones. There's a whole other back-end component to this, which is processing the data and actually extracting out the features and extracting out what the client needs, and then giving a deliverable. And I'll just kind of go to my next point here about consultative approach. You know, we as a company really trying to understand what are you trying to do first, and then we back into, okay, what deliverables would be most helpful, and then we go into what do we need to process, and ultimately how do we need to collect that data. But I bring this up because we work with a lot of other survey firms. We get calls from other survey firms that this just is not their specialty, and one of the reasons is because, again, you can go buy a DJI drone. That's not a hard thing to do. But the software, the analysis, the expertise, the processing, all of that is a big undertaking. And we've learned over the last couple of years, haven't we, Owen, that there is a lot that goes into that. So we work with tons of companies, survey companies, that get contracts that just say, hey, guys, we want you guys to go fly it for these types of purposes. And then safety, obviously, is an important piece of this. And then the asset management we kind of briefly touched on. And then last but not least, and I don't mean to call this out too much here, but obviously you should definitely use Ascent Geomatics 100% of the time when you're going to use these types, or use UAVs or LiDAR for these projects. So safety culture, obviously, this is my last slide here. This is very important. You know, working with a company that's going to be flying equipment over people's heads or properties, it's very important that they have a very intense safety culture, as well as checklists and documented procedures. And you can see one of our signs here we use when we go on site for aerial operations. So having all those things in place really kind of separates companies that know what they're doing here from companies that do not. So with this, I'd like to thank everybody, but also start going through some questions. And I know we've had some questions rolling in as we've been going through. So for the sake of time, I'll just kind of take a couple of these questions here. So let's see. Let me see if I can. One question, how far can you go in a day?
Yeah.
Owen, do you want to take that one?
Yeah, I mean, I think Michael might have touched on this before, but it depends on terrain, takeoff capabilities, just like anything. There's a few different variables, but we can probably get somewhere between 5 to 8 to 9 miles on the initial actual data collection effort for the prelim. Once we have that established, we can increase that mileage because we already have the control. We've already been there if we need updated imagery.
Great. Another question here, is that a blanket BVLOS exemption or project specific? You probably want to take that one.
Yeah, we're looking at a blanket. We're trying to get a waiver for that because if you can develop out the correct SOPs and run it through the FAA and get the approval process going, you can get blanketed for certain types of projects in specific areas or types of airspace, realistically. Because again, not every type of airspace they're going to give you that exemption. If I'm going to go here in Denver, we have Denver International Airport. If I want to try and apply and do beyond visual line of sight within 5 miles of that, there's no way I can do that. But it just kind of depends on the situation. But yeah, we're looking for a little more of a blanketed approach to help a lot of these projects that are a little further out.
Okay. All right. So this question came through, and I think I got a few questions on this. So I'll just kind of wrap it into one. How does the client view and interact with the data? So obviously, let's wrap this into a bigger question that people always ask, which is, we're talking about massive data sets here, right? So how do clients actually consume this?
Yeah, and again, these point clouds can be very large. There are online platforms that we can deliver a 3D point cloud that you can scroll around in, zoom in, see different perspectives. As you saw for some of the scan data, we can put it into an online viewer to become that kind of scanner head perspective. And then ultimately, how do you consume it? It's really, you need the line work, you need the surface model. We're going to deliver you that, and like I said, the imagery and some of the other products we can deliver in sort of tiles and smaller packets of information that is actually usable. Otherwise, there's a few different methods that we can go about, and it just is very project specific and what type of point cloud, or what type of density would you want to see, and that becomes the basis for the delivery method.
And I think on top of that, you were basically just talking about data, but for the project manager, we have tools such as getting alignment sheets out, but also our petroleum asset manager PAM site has an interactive view where we can see up-to-date survey work and how our route for midstream is going along. We can also kick them out as KMZs, which most people are usually using for. So I think it just depends on, are you just trying to move your job along, or are you somebody consumable for just data? So either way, we can kick that out on a number of different convenient platforms.
Okay, great. Probably have time just because we're already 5 minutes over here. Maybe one more question here. Owen, I'm going to throw this one at you. How are you producing overhead data with ground-based LiDAR?
Yeah, so it's once again, we're performing a survey. Survey is all based on triangles. If you can see it from different perspectives, you can start to interpolate. So by having the ability, and even with those static scans where you saw that we had multiple setups, if you can see a similar point from a different area, you can create a three-dimensional surface out of it. It works the same with that backpack example that we showed you that you're asking about, that we had points from so many different angles that we eventually get the top of the wire, we get that full rounded perspective, and then even with tanks, we're able to see the top of tank without literally having to get on it or see it from above, from the ground. We interpolate that based off the real data.
And is it a true story here that you could, if you needed to, for whatever reason, we weren't able to capture that LiDAR data, we could capture some of that data with one of our UAVs and combine those data sets?
Yeah, yeah, definitely. We do that with some volumetrics. You can't always see the top of these earth piles from the ground, so you can put the bird up in the air and you can overfly that, and you can combine those data sets. And again, it's just like you were saying, there's not one tool is always going to get every single thing you need. It's a blended approach in how you collect it. It's just understanding what is needed. Do you need to see the top of that dirt pile? Then we're going to go out with that approach, knowing that we have to get the top of that dirt pile.
Okay, well, great. Well, thanks, Owen. Sounds like most of those questions are directed your way, but my contact information is here on this last slide here. If there's any additional questions, please jot either down the email address or the phone number, and you can reach out to me anytime. If you did leave your information in some of these other questions, I'll do my best to get back to you over the next day or so. And with that, I'd like to thank everybody for joining this webinar. And like I said, we will be posting this to our website if you want to go back and show it to some of your colleagues or review it again. Thanks again, and hope you guys have a good rest of your week.
All right, Dave, thanks.
Thanks, Michael. Thanks, Owen.